All right, folks. So let's start. So today we'll look at some aspects of authentication, and note that the authentication will continue for a very long time. Right now, we are talking only about the authentication in a standalone computer. Later on, we'll start talking about authentication over a network, right? Okay. So we'll look at some of the ways to authenticate. And of course, in last class, we studied about password. So we'll work on that and say that how to improve passwording technique. And we'll also look at some of the password cracking techniques. And once we know password cracking techniques, then we can improve on passwording system, okay? Or basic security system or access control system, all right? So these are the topics we'll cover. And please feel free to ask question in case you have any doubt anywhere.
Recording.
Okay. All right. Fine. Okay, so these are the topics that I've covered. These are the references for this talk. Okay. All right. So this is something that we studied in the last class. Idea of access control is to prove to somebody about your identity, right? Okay. So you can use, for example, ID card or ticket with printed ticket with photograph possibly, or maybe ticket and photograph. And systems we use user ID and the password. Okay. All right. So basic access control consists of mainly two things. First is authentication, where you present to sentry or security guard or system who you are. Okay. For example, it could be ID card or password. Okay. And then sentry here will allow if it matches with the credentials stored in the system. Okay. However, in order to go inside a system, you should be authorized. It means that although you can present identity to a sentry, and if you are trying to, get crash into some event, then sentry will see that whether you are allowed to participate or not. Okay. So that's called authorization. So one example of authorization is that OS is authorized to certain things. A user is not authorized, or user process is not authorized. Certain user processes are authorized to use certain resources. Okay. So not all processes that are running can use all the resource system, only certain are authorized, right? So authorization is equally important, right? And there are tools to have authorization and so on. And also, so basically what I want to say is that authentication, authorization put together provides access control. And this is a process that we have seen. All right, just a minute. Okay. So all this we have seen. Okay, and we have seen that most of breaches, breaches happen primarily to get credentials. Okay, so credential is very important thing that cyber criminals look forward to. Once they have credentials, they can sling into the system. Otherwise, getting in the system is extremely hard. Okay, is well protected, right? Simplest thing is to get credentials, user ID, password, and then get into the system, which is simplest possible way. Okay, if criminals are not able to get user ID passwords, then they have to think of what are the other holes in the system through which they can sneak in. Okay. All right. And this is the way in which passwords are stored. passwords used to be stored earlier in the plain text in the server, right? Or system. That was maybe many years back. So now it's very easy for so user will present the password, it will be hashed, and now this hashing function is known to everyone. Okay. For Unix system, for example, hashing function remains the same. And this hash password is stored, okay, which is string of fixed length. So we'll study hashing function maybe in after a few classes. So now this is stored. So it means that for all users, user ID and password are stored. And password, that too in hashed form, is stored in the system. So whenever a user presents the credentials, that's a user ID and password. Okay, so what system does is that to that password, it hashes and compares with a stored hash password, and if matches, then user is allowed to get in. Okay, any question? Why is this hashing used? Because if this file of all hash password, now if hashing is allowed, then a hash password is leaked, then cyber criminal has to do a lot of effort to break it. Okay, from this hash password to password, this process is quite difficult. It's not inverse function, it's a one-way mapping. Okay, so in order to get the password from set of hash passwords is quite an expensive process. All right, so if these passwords are stored in plain text, then cyber criminal is able to breach into the system. Then all plain or actual passwords or in the plain text is available. So that's the reason passwords are hashed and stored. Any question? All right, so this is the example that we have seen last class, that passwords are hashed and stored. So P is a password, then this is stored in the system, right? And that's for all users, not only one. Okay. Now the question is that cyber criminals are going to do this process, right? For example, for Alice, the password is P, and then server stored this as a hash from which is HP. Fine. Now let's assume the cyber criminals are able to break into this one, break into the system and gets HP for Alice and many other users, right? So they are able to steal HP. What they are going to do? They are going to crack it. Okay, from HP, they want to get P. So how will they get P? Although they know H hashing, because they known thing, they cannot get easily P. Okay, so only way is that, so basically hashing function say they will have to put something here, and this is available, HP is available, right? So for different values of X, maybe whatever combination of letters, digit, words, whatever, the way password is formed, they will apply one by one and get the value of, so now compare this with, say, HP, compare, which is a Alice's hash password. And for if one of the combination of specific value of or specific value of X, if HX matches with HP, then X is the password. All right, got it? And the life of cyber criminals is very simple now, because most of us use very simple password, right? 123456, which is most commonly used, or 12345678, or ABC123. Okay, so here whatever they are trying, value of x, they will first try with 1, 2, 3, 4, 5, 6, and use h of that, and then match with HP. If not, Alice is smarter, maybe she will have 1, 2, 3, 4, 5, 6, 7, 8. And again, they will check, or maybe ABC 1, 2, 3, etc. Right? So these combinations are known to cyber criminals also. They have already created a list of hashed this kind of passwords. And then the matching is quite simple. So now the question, of course, we will study all this little later in the class. The question I'm asking is how to make the whole process little difficult for hackers. Okay, for example, I am using password. Say my name is Ravi, or I am using, for example, my name is Ravi, although I am using a password IIT Goa 123. This I will remember. Okay, and it will be hashed and kept in the system. Now you are using, for example, same password. It's very likely that one of you will use is IIT Goa 123. Okay, now these two hash passwords are same. So cyber criminals will know that this is if two hash outputs are same, they will know that very likely there's a common password. Okay, that both of us are using. So we'll use dictionary words or these combinations able to break in. Now, idea is that although both of us are using IIT Go 123 as password, but hash output should be different. How is it possible? Think about it. Okay. So way it's possible is that attach some salt to password, which is nothing but a randomly generated sequence of letters and characters, right? Letters and maybe special characters and so on. Okay, that we call is password salt. Okay, so it provides randomness to password. Although both of us are using IIT Goa 123. Okay, and then this salt that is added to it, which could be either, usually it's put after or it could be before. This, for example, this is say X, Y, Z, A, B, 1, 2, whatever. And if for you, this could be different. Say it could be P, Q, R, S, 1, 2 star or whatever. Okay. Now, when you apply H to this, we call it say H of P or say something, right? Say previous password PP, and then H of later password. Okay, both will be different. Okay, so now is causing now little complexity or difficulty for hacker. Could you think of any other advantage of adding salt?
But sir, adding salt would also be difficult for us also, like when we are matching passwords.
You are not doing it. It is system that's adding salt. User cannot add salt, right? It means
No,
that you are
sir.
changing
Uh,
password, right? Yeah.
like I have registered with some password, and now when I try to log in again,
Mm-hmm.
then how? Then when checking, till now like it is checking by comparing the value of hash function, right, sir?
Yeah, yeah.
But now
So
the hash.
I understand your question. Now you are also storing. See, this salt is applied when you are setting up the password in the beginning, right? Okay, not every instance when you're checking it, right? So salt is applied, and then value of salt and total hash value of salt plus actual password is kept in the system. So I'll take the example. Okay, so it's like this. So now let's assume that your password is Sanjay123. Okay, and you apply a random salt S41T. Okay, it could be anything or any length, system dependent. Unix may have defined something. Similarly, other systems will have, other OS will have different kind of mechanisms, right? So now this is a salt. So total password, salted password is this S41T Sanjay123, right? Now you're doing at the time of setting, you are setting the password right in the beginning. So now you apply hash function to this and store in the table salted hash. It means that hash of this one S41T Sanjay123, hash of that. Okay, and also storing the value of salt in the same table. Okay, now you want to input, you want to log in, right? So you present your password. You have presented only your password. Then the system will read this password, take this password, apply salt to it, and create this string. Okay, and do the hashing function. And now you have salted hash. Now this salted hash is compared with the stored salted hash, and if matches, then it's done. You are allowed to get inside. Okay. All right. Any question? Now you may ask this question. This now.
Salted
Yeah.
is salted hash same for every user, or is it
No,
different?
no. So it's a random string created for every user.
Then
And
when we input the password, how will the system know that they have to use
particular
this
salt.
particular salt?
Okay. Yeah. So let me just come back. Salt is not created by you. Okay. Salt is created by system. And when is it created? When for the first time you create login credentials, right? You want to log into say a system, and first time you are creating a user ID and password, right? Okay, or when you are changing your password
Yes, sir.
also, right? At that time, the server will create a random salt for you. Okay, and then random salt will remain the same for certain period of time. Okay, and then it will be stored. Salt value is also stored in the table along with password and salt and hash of that. But plain password is not stored, right? So this salted hash is there, which is after adding salt to your password is stored here, and also salt is also stored along with. Okay, now it will remain the same for some time. When you log in next time, then system will know this is your salt. It will apply to your password and do the hash. Okay, and then if the salted hash is same as one that's stored, then you are allowed. Okay, shall I repeat? Are you able to understand it?
Yes, sir. But what if like if I use login after so long time? Like suppose
No,
I
so that of course, whenever the salt is changing, see, you don't have to do anything because your password remains the same until you change the password. Or let's assume the salt also remains the same until a password is changed. Let's assume for that matter, right? You will just simply apply your password, and the system's responsibility to apply already when you already created salt, which was created earlier for you, and do the hash of both and check the value that is stored in the system, right? Salt value system will come to know, because when you have created login credentials, then at that time system would have created some salt for you, and that salt remains in the same password file. Okay, so let me, this diagram may be a little complex. Let me just show it here. Okay, so first is that suppose I decide that my password is, see, I am creating my credential to a system. Okay, we do create, right? So let me decide, I may have some login ID. Okay, and then password, I have decided that my password is Ravi123. Okay, so that system will allow me to do that, considering that it has adequate, is matching the requirement of number of characters, etc. Now, note that I am creating this. So system will have a table. So it will have user ID of, say, Ravi at ITG at whatever. Okay, and then it has to store my password. Okay, now at this point in time, when it receives my password, okay, so the system has received my password Ravi123. Now it has to store this, right? Now it cannot store in plain text form, it can store in a hash form, but before hashing, it adds a salt to it. So let's assume that now it generates a random string, okay? And then let's assume that the string is, say, 1 star 1 at the rate star x y or something of some length. Okay, this is called salt. Now this salt should be known. So this salt for me, 1 at the rate star x y is stored in the table. Okay, now what system will do, once it decided on the salt, it will take both my password and salt and hash it. Now hash function is known. Okay, and it's the same for all users. Okay, so now this hash value, say it could be, say for example D, F, whatever star, something of certain length. Okay, will be kept here. This is my salted hash. Sorry, salted hash will be kept here. Okay, that's done. So right in the beginning, this is happening. Now, after some time, I want to log in. So I will present my credential as Ravi123. Okay. It will go to system. What system will do? System will look at what is salt for me. Salt is here. So, so it will create, it will take Ravi123, add salt to this, which is 1 at the rate x, y, whatever, 1 at the rate star x, y. Take this and then hash it. Hash this string. Okay, hash of Ravi, whatever. 123 plus salt. Okay, it will get some value. Okay, now it will compare this value with stored salt. It's stored hashed password, salted password. And if it matches, then fine. All right, got it?
Yes, sir.
So user doesn't have to do anything. User have to just present credentials. System will add salt to that password, hash it, and compare it. If it matches, fine. Now the question you may ask is that what is the advantage of all this, right? Because multiple instances, people use the same password, then output or salted password for each one of that will be different. So it will cause difficulty to user, to hacker. That's one difficulty. What could be other difficulty? Okay, other difficulty could be when, for example, What could be other difficulties? Think about it. Okay, so if two users use the same password, hash value will be different. That's fine. So if no salt, then it's very simple to crack. Okay. Second is that if hasher uses the same password in multiple accounts, see, if hacker is able to crack the password, if it's unsalted, if you're not using salting, then that password can be applied everywhere, because hash value is the same. He will receive the same hash value in multiple breaches, okay, and can apply same password. Then his life is easier. Now, if you apply salt, then every breach, wherever you have an account, if you are using same password, the salted password that hacker will get will be different. Okay, all right. And so hacker will have to create a hash table for each value of salt as well, right? See, hackers don't try one by one things, right? They already create pre-compute. First they will take a commonly used password and pre-compute hashes of that, and so on and so forth, right? So this pre-computation part becomes very difficult because of salting, because salt could be very different for different users, right? And if salt is set 10 characters long, then for amount of combination would be humongous, right? So now pre-computation would become very difficult. Right? Say for example, 2-bit random solve, 12-bit random solve, the password could hash into 2 raised power different hash values. So now you are causing little difficulty to hackers. All right, got it? Anybody else? Anybody has a question?
Sir, I have a doubt. Sir, how do we know that the hackers do not have access to the salt values also along with the salted?
They have access to salt values also.
Sir, but if they have access to the salt values, then they can just I mean try out the like the rope, like the a method to hack to get the unhashed value, right? As they did for the password without salt.
Yeah, first thing you note is that you're right. You're right, but all you are getting after hacking is, as a hacker, hash password, right? Hash salted password. Okay, and then you and also is also getting salt. Fine.
Okay, sir. Yes, sir.
So now looking at this random combination and applying salt, and then you have to apply a random string, hoping that you will get it. Yes, I mean maybe yeah, the difficulty could be the same here, knowing value of salt. However, if these two are different, right? I mean, right? Then, for example, you are using same password in multiple accounts, then this would be different. So now hacker cannot do matching of these two and then reduce the work. Okay, so the first thing, using this is the primary advantage, that same, if multiple users are using same password, then output will look very different. So even the salt value is known, then hacker may not be able to, the salt value is known, but salt value would be different. So hacker cannot find out that these two that belongs to same password are actually correlated or have same password. So the work would increase. And also, if we add salt and also a password, the time required for hashing, even if the string is known, time required for hashing also goes up. Okay, so point is that by adding salt, you are trying to increase the difficulty or increase the time for hacking for a hacker. That's it. Given one password and salted password and corresponding value of salt, possibly it will take the same time, a little more time. But if the hacker is interested in doing this for a large number of users, then difficulty is of different order altogether. All right, think about it. Just think about it. This is an obvious question that comes to mind. But so salting does not take away all the problems. It just simply increases the complexity for hacker. All right, let's move on. So we'll come back if there is a question. So now there are a lot of problems with password that we have already studied. Somebody may be listening, somebody might have forgotten the password. Okay, and that's the reason people choose passwords that are easy to guess. And this becomes very simple for hackers to crack. Okay. Now what we are talking about is about ethical password cracking, because if you learn cracking of password, then think as a good person. Okay, whole idea is that system admin guys have to apply these techniques to see which user has a weak password. Okay, and then inform that user that he or she needs to change the password. Okay, otherwise, whatever be, if my password is Ravi, simple Ravi, and if I hash it, it will be of same length, even if my password is extremely complex, 1 2 V, whatever. If it is complex, if I hash it, okay, it will be again random string of the same length. So if system admin guy even looks at this, will not make out which user has a weaker password. Okay. So now remember one thing, that if you get any call or your relatives get any call about the password, somebody asking you for password, never give, because system admin guys don't know about your password and they don't need it. All right. Okay, they don't need it. All right. So password should remain absolutely confidential and should never be shared. Okay, so now come to common password hacking techniques. Social engineering is very common and very simple. Cost involved is very less. And it's heavily manipulated. We have seen in breaches, social engineering comes almost at the top, where human angle is involved. Okay. So basically, it is nothing but manipulating a person into knowing or knowingly or unknowingly giving up information. So say for example, someone, your friend, approaches you that I need some money, and you are somewhere else and you don't have access to system, and he needs money for some important work, and then you say that I am not close to system and so on, I don't have internet. He will say, just tell me user ID password and I should be able to do the transfer, right? And then person actually transfer more than whatever you allowed. Okay, so this is a social engineering trick. Okay, it's a psychological manipulation. Okay, so because we in general, as a human being, we trust each other. Okay, but this trust can be broken. Okay, so just an advice, side advice, when you do any financial transaction, you are selling a some property or something, even if it to your relative or friend, or everything should be in writing, and make sure that the financial plan backs it up, in the sense that think of all scenario. Now you are a security professional, you think of a threat scenario where somewhere in between, for example, person changes the mind, person doesn't want to pay you money, and so on and so forth. Okay, or the worst case, person may die, or person may postpone giving the money. Okay, think of all the scenario, come out with a document based on threats, come out with a document, and that should be part of the contract. And you can always discuss with, even if you're doing, say for example, property transaction worth say crores, even with your brother or cousin or sister or something, write this down and say that this is the basic rule that is followed. Okay, similarly in system, there has to be always, as security professional, think of threat scenarios. Okay, but in order to do that, you need to know the threat. So social engineering is one of the main ways of breaking up. All right, just a minute, my pen is gone. Okay. Next is some studies have been done. Okay, for example, the University of Sydney, 336 CS students were asked to email their password, and out of this, 138 returned. In fact, there was another experiment done that in one ice cream parlor, people were asked to, people were told that if they share their password for fun, then they will be given, 2 scoops of ice cream, most expensive ice cream, and most of the people agreed. A large number of people agreed to share password. Okay, and so on, right? So please go through it, and then you will find that this is a very good book. It's called Art of Deception by Mitnick. If you have time, please go through it. Okay. So how to avoid social engineering scams? So social engineering scams, don't ever give your user ID and password. It could be anybody. There's a huge amount of study happened in US and I think Europe as well, which is called intimate partner, based scams. Okay, so intimate partner is basically spouse. Okay, and it is seen that user ID, password, spouses share with each other, and if something happens, then something happens in the relationship, or break happens, or fights happen, then there's a big misuse of all this, right? So to be on safer side, never give. Okay, and I'll read all this. Treat incoming phone calls with skepticism. Treat incoming emails with suspicion. Whenever email comes from unknown person, never trust it. Okay, never double click on attachment, and so on, right? Okay, always check the source from where email or message has come. All right. Now this is another technique that is commonly used. It's called shoulder surfing. So this is again very common technique, and where somebody, when you are logging in, somebody comes close to you at the back and engages you in conversation, and then want to see what is your password. User ID anyway is known to people, right? Okay, so this is very common technique. As a result of that, and somebody can see it from the side angle as well, right? Okay, so many companies like IBM, I work, they gave a screen which can be put on top of the screen of laptop, is such that if somebody tries to see it from some angle, nothing is visible to person. Okay, so shoulder surfing is countermeasure is that be aware of who is around you, and somebody is around you, don't do login, or ask person to go away, or something like that. Okay. All right. Office surveillance is another technique wherein, okay, wherein, and this has been quite successfully used, because many people write their password either in diary or sticky notes, or they use some variation of password and then put this in a sticky note, and then it's all available on the desk. Okay, so when you're out of office, then this guy can come to your desk, and if diary is there, then try to find out your user ID and password. Remember, that's very important, right? There have been many instances where somebody who knows your user ID password, or someone's user ID password, has sent the email to the whole organization with all kind of things that person can think of, and as a result of that, the person has lost a job, because something goes from your account. It's your responsibility. Email is in your name. They will validate it has come from your account. Now, only possibility is that you have either shared the password, which is again not correct from company's perspective. Okay, nobody will think that somebody has stolen your password. If you let somebody steal your password, then that person can also steal your whole company's IPR. Okay, right? So don't ever share your password. Don't allow anybody to sit closer to you when you're doing user ID and password. And don't write down user ID passwords on a diary or something. Okay, if you write in a diary, then take it away with you whenever you're going out. Similar technique is called spidering. Okay, and now in organizations, seeing that most of the time passwords are selected by people based on the work they are doing. Suppose you are working on a web technology, right? Okay, then you will try to use that web technology, or you have an account, not your personal account, but account to do some work, then possibly you will keep user ID and password related to that, especially password. So you can say database 123 or Oracle 123 or whatever. Okay. Now the job of the cyber criminals is reduced if they know that most likely your password is related to this. Okay, so what do they do is that hackers crawl a company's social media accounts, marketing campaigns, manuals, and other corporate material, and they learn from that lingos, jargons, slogans, other languages, and then compile a word list for cracking. Okay, and usually enough material is available on social media sites, etc., etc. Right? And then this reduces the hacker's job. All right. Okay. And then if you are using some Unix utilities which are obsolete, okay, for example, rlogin, telnet, rcp, ftp, I'm sure you would have tried using some of these. You shouldn't use them. Why? These are very old. Okay, and then because they send the password in plain text. Okay, now over internet or something, you're sending password in plain text, then it can be stolen. Okay. So you use SSH or something like that we'll study later. Even if you are using some of these techniques, first create a encrypted session, and then do some communication, right? But avoid using these. These have been scrapped, and although some systems may have many of these, but never use this. Okay, all right. So there are many ways of cracking software. All right. Very simple way is that there are now tools available to crack the password of your neighbors who are using Wi-Fi. Okay. So there is a Wi-Fi scanner and all these are available. It comes in a system, actually you can buy it if you have money. It may not cost more than say $200 or something like that. So okay, and then see, Wi-Fi good or bad thing is that a lot of things are available to you, although it's in encrypted form, right? So for example, password in encrypted form is available. It's just one password, right? How many password a person is using? Just one or two passwords that will come from system. Okay, then hacking it becomes extremely simple. Okay, so we use WPA2 four-way handshake protocol when we use Wi-Fi. Okay, all right, and so we can look at the top one. Okay, that's one way. Okay, so now second is that you can get hash password from shadow file. Now we'll study shadow file in the next class. In Unix, there's a password file and this is called shadow file. So the encrypted password or hash password are kept in separate file, not in password file, but separate file is called shadow file. Now, if shadow file is available, then you can the hacker can always can crack it. Okay, using the techniques. All right, and the common methods are dictionary attack or rainbow table attack or brute force attack. Okay, of course, a lot of advancement in cracking techniques now, but we'll look at these three today in very brief. All right, so this is the one which we have studied earlier, that password is available to hackers in hashed form. Okay, and then it simply needs to once hash passwords are available, it has to apply different value, and hash function is known, apply different values of X or password and then get it. And if it matches with the hash value of the password that's available through stealing, then job is done. So now simplest one is use brute force attack. Okay, if the password is of certain length, then look at all the possibilities of that's possible for the string. Okay, so a password will have what? Lowercase letter or uppercase letter, a digit, and a special character. Okay, so if now look at the top table, if this is of length 1, so only one character, and it could be of any time, then there are 95 possibilities. Okay, now if it is of size say 8, which most of us are required to do in most of systems, then lowercase, in case of lowercase, you can see that 2.09 to 10⁻11 combinations are possible. Okay, if you use lowercase, uppercase, digit, and symbol, the last column, if you see with length 8, then number of possible combination of 6.63 into 10⁻15. Okay, and now you look at a common desktop and see how much time you'll require to crack. For example, here a password of length 8, which uses only lowercase, using a simple brute force method, it will take 2.42 days. Okay, now if using all combinations of lower, upper, digit, etc., then it will take 210 years. Okay, now if you increase the length of password to 16, you can see on an ordinary computer, it will take 1.4 quintillion years. So that's the reason most of the time it is said, whenever you set a password, system will insist you to use special characters, lower letter, upper letter, and so on of longer length. All right. So brute force method we have seen already is, and now of course you can do it on GPUs, graphic processor unit, and you can do 10⁸ MD5 hashes. Okay. So, and the numbers we have seen. All right. And then it's very simple because passwords are never random, right? Most of people don't use very random character password. So basically some pattern is there, and then this reduces the cracking time for a hacker, right? Okay, if it is salted password, then salt value is available to hacker. It has to apply different combination of a password, which is shown here in the green on the right hand side, and it has to now create a hash value and then compare it with something that he gets from hacking. Okay, stealing, which is available from the table, and compare the both and crack it, right? But note that this is hashing because of salting becomes slow. All right. Any question? Okay, another few minutes, then we'll stop. Dictionary attack is nothing but use commonly used password 1 2 3 4 5 6 or whatever, right? And all dictionary words. Okay, and use some statistics that most of the users don't use very long passwords. They use simple password and so on and so forth. Very rarely people use special characters. Okay, they use generally lowercase with digits and so on, and that's called dictionary attacks. It's kind of brute force attacks, but space is limited. First it checks all dictionary words and this commonly used passwords, and so it reduces the effort for hackers. Okay, for example, I will use Ravi 123 or my son's name 123 or whatever, or date of birth and year and so on. So all these combinations are available in the attacks. Okay. So next class we'll start. We'll briefly look at the rainbow tables. Now you look at it. This is cracking a software is nothing but optimization between time and memory. Okay, if you are doing brute force attack, your system is generating one string after other and applying hash function and checking. Okay, all right, so it does not require memory. On the other hand, you pre-compute hashes of everything. Pre-compute, the hashing requires time. It's a slow process, right? It's not very fast. Okay, now you create a table of hash value of all possible strings that are in dictionary or etc. Now do the comparison of already hashed values. Okay, so this is the other end where it will be a maximum amount of storage but less time. Now how do you optimize between the two? You understand what is the problem? See, either you need too much of space, so exhaustively you create hash of all possible combinations. Okay, and now the hashing time is only one time, right? In the beginning you do this, and once this output table is available to you, use that pre-computed table for comparison with the values that have been hacked or hash password, whatever available. You start checking and reduces your time significantly. Okay, but you need a huge amount of money. You may remind terabytes of money, memory. Okay, now that's not possible, until unless you have a very expensive processor, etc. Right? So you try to optimize, and rainbow table is one of the ways to optimize that. So maybe, although I want you to self-study it, but we'll go through it in the next class in very brief. All right. Okay. All right. So now, and of course, there are a lot of tools are available now. Some of the tools that you can actually try, cracking tools like Brutus, Knabel, JTR. JTR is very popular. This is another one, THC Hydra, All these are very popular tools. Try to get them, okay, and play with it. You'll get some feel. And there are a lot of GPU based tools. Actually, commercially you can buy tools, okay, which will have GPU, multiple GPUs, multiple processors, and of course there are cloud based tools because you don't have to spend money in buying, you can rent it. Okay. All right. To summarize, we have looked at some of the techniques, social engineering techniques, shoulder surfing, offline office surveillance kind, spidering, and then old Unix utilities like FTP, etc. Okay, and we have also looked at brute force attack, dictionary attack, and some offline tools we can use. Okay, rainbow table is left out, which you please go through PPT and try to understand, and then we'll study, possibly discuss it in brief in the next class. All right. Okay. Bye bye. Any question?